A warm welcome from Bharat Institute of Higher Education and Research. My name is Alan from Department of Computer Science and Engineering. I'm going to explain about the topic Introduction to Stacks and Queues from Data Structures and Algorithms. Before we go to the topic, we'll be just learning what is abstract data type. What is an abstract data type? Abstract, the term abstract refers hiding something. Hiding something and showing only the essential things. It is a data type defined by the user, typically more complex than simple data type like integer, float, etc. And what is this abstract? What is this term abstract? As I said earlier, abstract means hidden because the details of the implementation, how the things are working, right? How the operations are done, which will be hidden, and other essential things only will be shown. So that's what abstract refers to. Because details of the implementation are hidden, when you do some operation on the queue or stack, let's take an example for queue or stack, say inserting an element or deleting an element, you'll be just calling the function, okay? But you don't know how the process is done. So details how it is implemented or how the insertion function works. Other things are not shown, it is hidden out. So this is about the abstract data type. So I'm repeating it. What is an abstract data type? This abstract data type, it is a user-defined data type. So this is typically more complex than a simple data type. Like, so what are the simple data types? Integer, float, character, etc. So these are simple data type, but this abstract data type is somewhat typical, which is defined by the user. So what is an abstract? As I said earlier, abstract means hiding something. The implementation are hidden. So how the things are implemented, how the things are processed out are hidden out, and other things are shown. So that's what, because details of the implementation are hidden. When you do an operation, let's take for an example, when you do an insertion operation, probably it might be in queue or stack, you'll be just calling the function as what is the function insertion. You does not know what is the thing which is going behind. The implementation are hidden. Only you'll be receiving your. So details of how the list is implemented or how the insert function is required, which is no longer required. So this is about the abstract data type. So details of how list is implemented. List means what? It might be list or it might be queue or it might be stack. Implementation. Details of how the implementation or how the function is written is no longer required. Implementation it is not needed. This is about the abstract data type. And about the abstract data type, more about the abstract data type. Abstract data type, it is a designing tool, very important. It is a designing tool which concerns only on the important concepts, which takes only the important concepts or model. It does not care about it, no concern on, it does not care about the implementation details. It does not care about the implementation details. So very important thing. So abstract data type, it is a design tool. Abstract data type is what? It is a designing tool. It takes the concern only on the important concept or model. Only the concept it is taken. And it does not care about the implementation detail. No concern on implementation details. Abstract data type, it's a designing tool. Concern only on the important concepts or model. Concerns only on the important concept or model. No concern on implementation details. So a very good example of abstract data types are stack and queue. So this stack and queue, it is an ADT, it is an example of abstract data type. Implementation, it does not care about the implementation. Stacks and queue does not care about the implementation. So it is an ADT, abstract data type. An array, it is not an abstract data type. It cares about the implementation. It is not an abstract data type. But stack and queue is a good example of ADT. It concerns only on the important concepts or models. It does not concern on the implementation details. Stack and queue are the example of ADT. And array, it is not a ADT, abstract data type. So what is the difference between stack and queue versus array? So you know what is an array, right? Array is what? Array is a collection of same elements, homogeneous elements. So array are data store structure, while stacks and queues are specified and used as a programmer tools. So array is what? Array are data structures, while the stacks and queue are specified as Programmers tool. So stack, what is a stack? Stack is a container that allows two different operations, which is push and pop. In other words, you can add it as insertion and deletion. Stack is what? It's a container, a normal container that allows two different operations, which is push and pop. So stack is a container that allows push and pop. As I said, stacks are specially used as a programmer tool. Stacks and queue are specially used as a programmer tools. And queue, the name itself says queue. It is also a container that allows a two different process, which is called enqueue and dequeue. What is enqueue? Enqueue and dequeue. Enqueue and dequeue are inserting and deletion element. Push and pop are also insertion element, insertion and deleting an element, which is used only in stack. But in queue, we'll be using some different operation called enqueue and dequeue, which is none other than inserting an element as well as deleting an element. So no, it does not care about implementation. It does not. Why it does not care about an implementation? It is an ADT, abstract data type. No concern on implementation detail. It does not bother about the implementation. So stack and queue, the difference between stack, queue, and array. Array is what? It is a collection of same element. It is a normal data structure, normal data storage. But while stack and queue are specified programmer tool, as I said, stack, it is a container that allows push and pop, and queue, a container that allows enqueue and dequeue, which both stack and queue will follow the insertion and deletion operation indifferently. So stack, which follows push and pop, and queue, which follows enqueue and dequeue. And those two different data structure, which does not care about implementation. No concern on implementation. That's about it. In an array, any item can be accessed. While seeing about the accessing part, in an array data structure, any item can be accessed easily. While in these data structure, in the stack and queue data structure, access is restricted since it is an abstract data type. In array, the accessing of data is very flexible. In an array, any item in an array can be accessed easily. It can be accessed easily. It can be accessed. But in those data structures, the stack and queue. While in this data structure, what are those data structures? Stack and queue. Access is restricted. Why? Because it is an abstract data type, ADT, stack and queue. Good example of ADT. So that is about the accessing part. So in an array, you can easily access the elements, but in stack and queue, you can't easily access the element because it is an abstract data type. And there are more abstract, they are more abstract than arrays. So this stack and queue, they are more abstract, very more abstract than arrays. Why? And the accessing is also very hard. That's about it. Okay. So very important thing. It is a data structure. Array is a data structure, but queues and stack, it is a programming tool. Stack is a container which follows the push and pop. That's what the insertion and deletion element. Queue, a container that allows enqueue and dequeue, which is also inserting and deleting an element. Both data structure does not bother about the implementation. In an array, elements, data can be accessed. While in these two different data structures, the queue and stack, access is restricted. Why? Because it is an ADT, abstract data type. So these are more abstract than arrays. So now we'll see what is a stack. So stack, it is a data structure which follows a principle called last in, first out. Last in, first out. So we'll take an example of a pile of plates which are arranged. So let's assume in a dining hall there are a pile of plates which are arranged. The first plate which is cleaned and it is kept will be at the last part, and the last plate which is cleaned and kept will be kept at the first. So when a person is coming and taking the plate, he'll be taking the first plate in the pipe. So that is last in and first out. LIFO, last in, first out. So stack follows the principle of last in, first out mechanism. The principle of stack, the mechanism of stack, the principle and mechanism of stack is LIFO, last in, first out. So this allows to only the last item inserted. Stack allows the access to only the last item inserted. Only one item at a time. Only the last item, only the last end of the item which is inserted at a time. An item which is inserted or removed from the stack from one end, only one end. It can be, see, the insertion and deletion. See, the inserting an element or deleting an element from the stack can be done only at the one end of the stack, where only at the top end of the stack. So that is the main important thing of a stack. So far, we have seen about three important things. First one, stack, it is a data structure which follows the mechanism. Stack, which is a data structure which follows the mechanism of last in, first out. Principle of last in, first out. Apart from it, it allows the access to only the last item inserted. The accessing of item. Which item? The item which was inserted at the last will be done. And what is the third point? The insertion and deletion. That's what inserting an element and removing element from the stack can be done only at the one end of the stack, where only the one end of the stack, from the top of the stack, only from the top of the stack. So an inserting an element and removing an element can be done only at the one end of the stack, from the top end of the stack. So this is the stack. As you can see in this diagram below, which is given over here. So here there are two different operations: the pushing and popping. So pushing is inserting an element, and popping is removing an element. Pushing is inserting a new element, and popping means removing an element. So stack follows last in, first out. So which was the last element? 5 was the last element. So this 5 element, the element which was inserted last, will be moving out first. So now, so here, first one, they would have inserted first element, element 1. So which is the top position of the first element? Element 1, and then 2, which is the top 2. And now when 3 was inserted, which was the top element? 3. Then when 4 was inserted, which was the last element? Which was the top element? 4. And last, when 5 was inserted, which was the top element? 5. So that's it. It says first in, last out. So first in, last in, first out. First in, last out. First in, last out. And last in, first out. Last in, first out. So this mechanism follows what? Last in, first out. So there are two different operations in the stack: push and pop. Push and pop. Inserting and deleting. Inserting an element and deleting an element. So the stack operation, as I have said already. So here, placing a data item on the top is called pushing. So which is said to be a first one, this is the empty stack. So now the stack is empty. So pushing an item inside the stack. So now what element is pushed inside the stack? Element 1 is pushed inside the stack, and that is the top of the stack, because no other element is inserted, no other element is pushed. So what is the place of element 1? Top. So now when second element is pushed out, so the top element is what? 2. When third element is pushed in, what element? Which third element is in? Top. So that's what. So this is pushing, insertion, and deleting. When the 3 is popped out, deleting out. So which element is top? 2. When 2 is popped out, which element is top? 1. It goes on. So this is what? Pushing and popping. So in stack, there are two exceptional conditions. There are two different exceptional conditions. An attempt of inserting a new element when the when the stack is full. An attempt of inserting a new element when the stack is full, it is called overflow. You must know an attempt of trying to insert a new element when the stack is full, it is called overflow. That is an exception. And another exception, an attempt of deleting an element when the stack is empty. An attempt of deleting an element when the stack is empty. It is called underflow. So there are two different exceptional conditions, overflow and underflow. There are two different exceptional conditions, the overflow and underflow of a stack. So what is overflow? An attempt of inserting a new element inside the stack. When the stack is full, it is called overflow. And what is underflow? An attempt of deleting an element from the stack. When the stack is empty, it is called underflow. So these are the two different exceptional conditions in a stack. So now you would have understood what is push and what is pop, and what is top element, and what are the two different exceptional conditions. So placing a data item on the top is called pushing, while removing an item from the top is called popping. So first point says that two different operations, pushing and popping. Placing a data item, an element on the top is called pushing. On the top is called pushing because there is only one element. So one is the top. So it goes down, it comes one, it comes here. So that is the top. So placing a data item on the top is called pushing, while removing an item from the top is called popping. When I'm just removing element 3, it is called popping. So now the top element is what? 2. So that's what push and pop are the primary stack operation. So inserting and deleting, push and pop are the primary stack operation. Some of the applications are what? Some of the application of what? Stack operations are microprocessor and some older calculators, etc. Microprocessor and some older calculators will follow the stack operation. So these are the applications where stacks are used. So the main operation of a stack is push and pop. Okay, and apart from it, the exceptional conditions are overflow and underflow. What is overflow? An attempt of inserting a new element inside the stack. When the stack is full, it is called overflow. An attempt of deleting an element when the stack is empty, it is called underflow. These are the two different exceptional conditions of a stack. Now we'll move on to the next important topic, which is called queue. So this is the queue, as you can see. So queue, it is also a DADD abstract data type, similar to stack, except the first item to be inserted is the first one to be removed. So listen carefully. So queue follows a mechanism called FIFO. What is FIFO? First in, first out. Let's take an example. When you are standing in a ticket counter, in a railway ticket counter, the person who is standing in the first queue, in the first place of the queue, he'll be getting the ticket and he'll be moving out. Same as like the second person, same as like the third person, it goes on. So that is removing. And when a person coming late, when a person coming late and when he will be joining the queue, he'll be adding at the last part of the queue. So when a person, when he is late to the queue, he'll be added to the last part of the queue and he'll be waiting to the first person to complete it. So that is called first in, first out. When the first process is completed, the first element will be moved out. So inserting an element will be done at the last part of the queue. Deleting an element will be done at the first end, the first part of the queue. So there are two different parts of the queue, the front end and the rear end. So there are two different parts of the queue, the front end and the rear end. What is the front end? The first part of the queue. And what is the rear end? The last part of the queue. As I said, the insertion. So that's what a person who is late, he'll be just joining the queue where? The last part. So that's what this picture shows. So people are standing in the queue. The first person is completing, is getting the ticket and is moving out. This picture shows you. The person who is going to come, who is going to be late for the queue, will be adding to the last part of the queue. So that's what. So this is front end and this is rear end. So deletion will be done in the rear and front end of the queue. So deleting an element will be done in the front end of the queue and inserting a new element will be done in the rear end of the queue. So that is the mechanism. That is the principle of queue, first in, first out. So as I said earlier, what is a queue? Queue is a ADT, abstract data structure, similar to stack, same as like the stack. So things are hidden. The implementation is hidden, except that the first item to be inserted in the first one to be removed. So the mechanism is what? First in, first out. Placing an item in a queue is called inserting. So insertion part is called as queue, which is done at the end of the rare end of the queue, last end of the queue. So this end of the queue is called rare. And last part of the queue, it is called rare, R-E-A-R, rare. So insertion will be called as enqueue. So enqueue operation will be done at the end of the queue, which is the rare end of the queue, rare part of the queue. And removing an item, taking an item from the queue is called deletion or dequeuing. Dequeue. Only in queue you will be using this dequeue and enqueue. Dequeue means deleting. So which is done only at the front end of the queue, which is done only at the front end, the first part, front end of the queue. So deleting in insertion, that's what enqueue, which will be done at the rare end of the queue. And removing an element from the queue will be, that's what dequeuing an element from the queue will be done in the front of the queue, front part of the queue, rare end and front end of the queue. So some of the applications which uses queue are printer, keystroke queue, it's a printer queue. That's what you would have seen in printer. When a job is a printing job, first job is created, other job has to be waited. Other two, second job has to be waited, third job has to be waited. Once the first job is completed, second it takes the printer takes the second job to be printed. So that is the application of a queue. So it follows the mechanism, the principle of first in, first out. As you can see this picture. So this is a queue, front end and the rear end. Insertion will be done in the rear end and deletion will be done on the front end of the queue. Types of queue. Circular queue. So circular queue. So when a new, that's what the circular queue is a queue where the first part and the last part meets together. The starting and the ending of a queue meets in the same place. It is called only then it forms a circular queue. The new item is inserted at the rear end. At the rear end of the pointer to rear moves the upward. What is a pointer? Pointer which holds the address. Pointer which holds the address of the next element. Pointer holds the address of a data where it is stored. Pointer is what? Pointer stores the address of a data where it is stored. So similarly, so when a new item is inserted at the rear means what? At the last part of a queue. The pointer to rear moves upward. The pointer moves upward. Similarly, when an item is deleted from the queue, then the front end moves downward, the opposite. So inserting, it rear moves upward, and deleting, the front end moves downwards. So these are the two important things for a circular queue. So when a new item is inserted at the rear, the pointer to rear moves upwards. This is done only in the insertion part. And similarly, when the item is deleted from the queue, the front end moves downward. So for insertion, the rear moves upward, and for deletion, the front end moves downwards. You must understand the difference between the insertion and deletion. Okay, so that's about it. So after a few insert and deleting operation, the rear end might reach the end of the queue, and no more items can be inserted. Although the item from the front of the queue has been deleted and there is a space in the queue, as you can see in this part from 6, 7, 8, and 9. As you can see from queue 6, 7, 8, and 9, although it was deleted and the space is free, you can't add more number of elements. Can you all understand it? Why? Because similarly, when an item is deleted from the queue, the front end moves downwards, and when the item is inserted at the rear, the pointer to rear moves upwards. So this is how the circular queue works. As you can see in this picture which is given, although there is a space, as well as the elements are deleted, you can't add more elements to it. So that is about the circular queue. And to solve this problem, queue implement wrapping around such queues, which is called circular queue. So that is about the wrapping around such queues, which is called circular queue. Both the fronted and the rear pointer wraps around to the array. It is called ring buffer. To solve this problem, queues implement wrapping around such queues are called circular queues. Both the front and the rear pointer wrap around the array. It is called ring buffer. To solve this problem, queues implement wrapping around such queues are called circular queues. Both the front and the rear pointer wrap around the beginning of the array. This is called the ring buffer. Item can be inserted and deleted from the queue in big O of one time, which this says about the time complexity. Time complexity, the insertion and the deletion. It says about big O of, so that is the much time, that is the worst case time, the big O of one time, which is taken for insertion and deletion, time complexity. As you can see, there are different various queues. The normal queue, which follows the first in and first out. So this is about the time complexity. Big O, it is the worst case. Big O of one, time complexity, time. The time taken for inserting and deleting operation. So various queues. Normal queue, which follows the FIFO, which is first in, first out. Circular queue, normal queue. Double-ended queue, queue, and priority queue. Double-ended. So there are four different queues: normal queue, circular queue, double-ended queue, and priority queue. There are four different types of queue, which is the normal queue, circular queue, double-ended queue, and the priority queue, DQ. So this DQ, which is called double-ended queue. So DQ, we will be calling DQ as double-ended queue. Item can be inserted and deleted from either ends. So there is a queue. Insertion and deletion can be done at both the ends, either ends of a queue. That is called double-ended queue. More versatile data structure than stack or queue. Then stack or queue. So that is about the DQ. So DQ is what? Double-ended queue. Item can be inserted and deleted from either ends. Items can be inserted and deleted. Any item can be inserted or same item can be deleted from both ends, from the rear end as well as the front end of the queue. So that's why it is more versatile data structure than normal stack and normal queue. So that is about the double-ended queue, DQ. So double-ended queue, which is also called DQ, DQ. So it is a DQ is what? It is a double-ended queue. Items can be inserted and deleted from the either ends. More versatile data structure than stack or queue. So priority queue. So the name itself says about the priority queue. It is more specialized data structure, which is similar to queue, having front and rear. Items are removed from the front. Items are ordered by key value. So through this key value, each item will have a key value. The highest priority of those key values will be taken and it will be processed out in this queue. Let's assume there are 4 number of elements. The element 3, which has the key value as more, key value is more. So the priority will be given to the third element, which has high key value, and the third element will be taken and it will be processed out. So items are ordered by key value, so that item will be taken as the highest priority. Item will be taken as the highest priority with the lowest key. Is always at the front. So that's what. So items are ordered by the key value, so that the item with the lowest key or highest is always at the front part. So the priority will be given. That's why priority queue refers. Priority means priority to the will be given to the data which has highest lowest value at the front end. Items are inserted in proper position to maintain the order. Arranging. That's what this 1, 2, 3, 4, and 5th point says that about the arranging. Items are inserted in proper position to maintain the order. So that is about the priority queue. I hope you would have understood it. Thank you. Thank you, everyone.